So this is a linear system of equations that contains brackets in it. So it's a bit more involved. All it requires is a little bit of simplification from the start before you decide to use either the method of elimination or substitution to solve. So let's begin. Here are our equations here. I need to simplify them. Okay, so the first one, I have two sets of brackets. What I'm going to do is apply my distributive property into each set. So I'm going to multiply the 4 inside here and here, the negative 5 over here and over here. So equation 1 becomes 8x minus 4 negative 5y plus 15 equals negative 18. Now, instead of simplifying this further at this moment, I want to focus my attention on the second one as well. I want to remove these brackets by multiplying in the coefficients in front. So my second equation will be 3x minus 15 plus 6y plus 24 equals negative x plus y plus 2. Okay, so I've eliminated my brackets. Now I can start collecting like terms. So my first equation, let me just put some lines here to separate my work. I have nothing with 8x, so I'm just going to copy that again. I have nothing with the negative 5y, so I'll copy that again. And I'll put all the coefficients on my right-hand side. So I have negative 18. It'll be plus 4 because the negative 4 switches sides, and it'll be minus 15 because the negative 15 switches sides. So I'll just clean that up a little bit. So that's the first equation, simplified. In fact, if I want, I can even go further just to save some time and space. If I add all this together, I end up with negative 29. So I'll just get rid of all this and replace it with negative 29. Now my second equation, I'm going to bring my like terms together. So I have a 3x here, and the negative x will give me 3x plus x. Positive 6y and positive y on this side will give me positive 6y minus y. Again, these two terms are changing signs because I'm bringing them to the other side of the equation. Finally, let me just delete some of this stuff here. Finally, I have my coefficients, so I'll have 2 minus 24 plus 15, minus 24 plus 15. So all this can be simplified even further. I'm going to do it right here. The 3x and x becomes 4x. The 6y and negative y becomes 5y. So I'll have plus 5y. And all these coefficients here become, let's see, negative 15, 17, negative 27. Sorry, negative 7. This is all equal to negative 7. So those are my two equations, simplified, much more recognizable in terms of we know how to work with them. And the method that jumps out at me right away, because it's going to take the least amount of work, is elimination. Notice I have a negative 5y and a positive 5y here. So if I add the two equations together, that will eliminate the 5y, eliminate the y variable, and I get to solve for x. So let's add them together. 8 and 4 gives me 12. The negative 5y and positive 5y is 0, which I'm not going to bother writing. And then if I add negative 29 and negative 7, I obtain negative 36. So 12x is equal to negative 36. Divide both sides by 12. And I obtain x equals negative 3. So there's my first value for x of my point of intersection. Now to solve for y, I can take this negative 3 and substitute it into, look, you can always go back to the original two equations if you want, but I would recommend using the simplified version of those equations because there's less calculation involved. So I'm going to pick the second one here, just because the numbers 4 and 5 and negative 7 are, they look nicer. Let's just put it that way. It feels better to plug them into that equation. And I'm going to replace the x here with a negative 3. That's this negative 3 plus 5y equals negative 7. Now once I do all the work here, you know what, let me bring this underneath. I'm going to actually move this first, give myself some more space. So here's my work. When I multiply this out, I have negative 12 plus 5y equals negative 7. 5y is equal to negative 7 plus 12 gives me 5. And it looks like my final answer for y is 1. And there you have it. Your x and y value, which means our point of intersection is equal to negative 3, 1.